let us discuss this question. So the diagram shows a uniform mass and m and radius is basically a, and if the moment of inertia of the ring about the axis PQ, this is the axis PQ, this is I which is given, then the moment of inertia of the axis of the ring about the axis XY. What is the moment of inertia about this axis? So what I am going to do is, I need to find the moment of inertia of this ring or disc, whatever it is, about this axis. So that is what I need to find, and this is given as I. So I'll call it ICM, because these two lines, they are parallel, and this axis is also passing through the center of mass. So this is why I am calling it ICM. Just apply the formula, and for the parallel axis theorem, formula is I equals to ICM plus MD square. So here the moment of inertia, this ICM we need to find. So I'll write ICM I need to find. The I is I and the MD square. So mass is M and the distance is basically A by 2. So A by 2 square of that. So that ICM is the thing which we need to find, and that is going to be I minus MA square by 4. And this is the answer. Now if we want to further get the answer, then I will say that this is a uniform ring. Now we already know that for the uniform ring, this moment of inertia is what? mr square by 2, right? So I know that this mr square by 2 I need to find. That is my ICM, and this I is what? This I is nothing but mr square by 2, that r is A, plus MD square, which is MA square by 4, and this is also A. So I'll say it is basically MA square half plus 1/4, that is going to give me 3/4, and that is I. So what is the value of MA square? The value of MA square is going to be 4I by 3. And now what do we need to find? We needed to find MA square by 2. So MA square by 2 is going to be this, which is 2I by, which is going to be 2I by 3. So either you say this is the answer or this is the answer. Depends on option, which options are given. If answer is in terms of I, M and A, then we give this answer. And if answer is in the term of I only, then this is the answer which you have to give. Now, let us discuss the next concept, that is radius of gyration. So what is radius of gyration? Basically, if the particle of same mass is placed at a distance equal to radius of gyration from the axis of rotation, then it will bear the same moment of inertia as the body has. Now, see, how do we do that? If this is a ring, I am taking the example of a, let us take the example of a disc. So this is a disc and this is the axis I am talking about. So this is a disc having m mass, r radius. So moment of inertia about this axis is going to be mr square by 2. Now I will say, what will be the radius of gyration? To get the radius of gyration, you always have to do this I is equal to mk square. What does that mean? That means for the same axis, if I have to take the entire mass, if I have to take the entire mass and I have to put it somewhere at some distance, let's say k, then moment of inertia, the same mass m, then moment of inertia is going to be mk square. And I would say the moment of inertia should remain same. So I can just equate these two. So that's why you can write I equals to mk square. And when you do that, you get mr square by 2, that is I is equal to mk square. And eventually this k is a distance and this comes to be r by root 2 in this particular case. So radius of gyration is nothing but ratio of moment of inertia divided by mass and square root of that. And it is, what does it represent? It represents that distance where if you take the entire mass and put it there, then it gives you the same moment of inertia. So this radius of gyration is useful, but that is different as per the object and axis. The radius of gyration also differs in all our different cases.